Myself Ravikran, along with me, my teammate Gopal. We have done a project on the nanotechnology in textile industry. Today I am going to explain about nanotechnology in textile. In this presentation, you are going to learn about how technology is being developed in the textile industry. What is nanotextiles? It is an emerging and interesting application of nanotechnology. It involves dealing with nanofibers at the atomic and molecular levels in order to tweak their properties. This novel technology can give rise to incredible clothing such as water resistance and dirt-free clothes, odorless socks and intelligent clothes that can perform climate control for you. In this visual presentation, you are going to see about the waterproofing with nanotechnology. Swiss chemists have developed a waterproof nano fabric that does not get wet. Researchers from the University of Zurich made this fabric from polyester fibers that are coated with minute silicone filaments. They also claim that this fabric is the most water repellent clothing material available till date. The principle behind the fabric's water resistance is the 40 nanometer wide silicon nanofilaments are extremely hydrophobic in nature. Moreover, their spiky structure enhances the surface chemistry and forms a protective coating on the fabric to prevent water droplets from entering or soaking the cloth. The coating's nanostructure and the hydrophobic property together produce this super hydrophobic effect in the fabric. Several types of materials used in the clothing, including microbe-killing silver. Silver nanoparticles are added to clothing for their powerful ability to kill bacteria and fungi and to prevent the nasty odors they cause. Nanosilver particles release positively charged ions that stop bacterial cells functioning. The particle's tiny size means the garment stays soft and wearable. Silica was waterproofing and stain resistance. Nanoparticles of silica incorporated into the wave of a fabric or sprayed onto its surface create a coating that repels water and stain producing liquids. The angle and roughness of silica coating creates enough surface tension to ensure that liquids form beats the troll of the fabric rather than soaking into it. Sun blocking titanium dioxide and zinc oxide. Ever got sunburned through your t-shirt? Nanoparticles of titanium dioxide or zinc oxide are incorporated into textiles to protect your garments and your skin from sun damage. Both particles scatter the ultraviolet light in sunlight and do so more effectively as nanoparticles rather than as large particles. Antistatic particles. Some fabrics, particularly synthetic such as polyester and nylon, tend to gather static charge. Whisk a top over your head and your hair stands on end. But nanoparticles that conduct electricity such as zinc oxide, titanium dioxide and antimony doped tin oxide can help disperse this charge. At the moment, clothes featuring nanotechnology are largely made from standard fabrics upon which a nano coating has been applied. But in the future, we are likely to see more fabrics made from nanofibers with nanoparticles and nanofilaments an integral part of the web. A new era of smart fabrics, for example, could automatically respond to your body and the environment around you. Physics behind nanoclothing. There are various nanoparticles were used to manufacture a nanocloth. Each nanoparticles have their different properties. Silver nanoparticles. By adding this particle, it helps to prevent the bacteria to enter in our clothes. Iron nanoparticles. The properties of iron particles are it has a good conductive magnetic properties and remote heating. Zinc oxide and titanium dioxide. These particles protect us from UV radiation, fiber protection, and oxidative catalysis. Titanium dioxide and magnesium oxide. By adding these particles to cloth, it has a chemical and biological protective performance, provides self-sterilizing function. Silicon dioxide and aluminum dioxide nanoparticles with polyethylene or polypropylene coating. These particles and coating of polypropylene or polyethylene gives water repellent finishing. Indium tin oxide nanoparticles. These particles protect us from electromagnetic radiation and infrared protection. Ceramic nanoparticles. It gives increasing in resistance to abrasion. carbon black nanoparticles, increasing resistance to abrasion, chemical resistance and impart electrical conductivity. Modern cost to produce a cloth manufactured by using nanotechnology. The cost of bacteria resistance nanofiber fabric clothing $14.9 to $16.5 per yard. The cost of electromagnetic radio frequency and microwave shielding protection is $19.74 per square meter. Twill Chief Value Cotton (CVC) Anti-tear workwear nano care fabric. This product cost varies from $1.5 to $1.99 per meter. Functional silver fabric for antimicrobial sportswear is cost around $0.65 to $1.3 per meter. How nanotechnology influences our daily life. Smart textiles are fabrics that have been designed and manufactured to include technologies that provide the wearer with increased functionality. These textiles have numerous potential applications such as the ability to communicate with other devices, conduct energy transform into other materials and protect the wearer from environmental hazards. Research and development towards wearable textile based personal systems allowing health monitoring protection and safety and healthy lifestyle gained strong interest during the last few years. Smart fabrics and interactive textiles activities include personal health management through integration validation and use of smart clothing and other network mobile devices as well as projects targeting the full integration of sensors, energy sources, processing and communicating within the clothes to enable personal applications such as protection, safety, emergency and healthcare. Nano fabric technology adds special features that help maintain the body's well-being. They are antibacterial and by preventing bacteria from coming in contact, you reduce the chance of getting sick. Nano fabrics also improve your circulation, consequently reducing swelling. They are anti-allergenic, allowing anyone to wear them. They are deodorized, therefore making the wearer smell better. Additionally, nanofabric clothing prevents sun exposure by being anti-UV. The special health benefits contribute to the nanofabric success.
Smart clothing is the fusion of textiles and technology, which can be used in a wide variety of applications in both professional and regular life. Some of these fabrics gather energy from the environment by harnessing vibrations, sound, or heat, reacting to the input. Performance-enhancing smart textiles can measure and report vital signs for patient healthcare, fitness training, or the handling of hazardous materials. There are fabrics that help regulate body temperature, reduce wind resistance, and control muscle vibration, all of which help improve athletic performance. Aesthetic uses of smart clothing includes everything from fabrics that light up to fabrics that can change color or resist water and pollutants of any kind. The health and beauty industry is taking advantage of these innovations, which range from medicine-releasing textiles to fabric with moisturizer, perfume, and anti-aging properties. Let's take a closer look.
How the nanotechnology changes in time in textile industry. The first generation of nano enhanced textiles benefited from a nano finishing. Coating the surface of textiles and clothing with nanoparticles is an approach to a production of highly active surfaces to have UV blocking, antimicrobial, antistatic, flame, retardant, water and oil repellent, wrinkle resistant and self-cleaning properties. In future, we are going to use electronics in textiles. We have written extensively about smart textiles for instance, energy scavenging fabrics that lead to wearable smart clothes that can power integrated electronics and sensors through ordinary body movements, interwoven solar cells that turn t-shirts into power textiles, a wearable textile battery that can be recharged by sunlight, nanoelectronics at the tip of a gloved finger, graphene yarns that facilitate energy storage textiles, graphene coated e-textile that detect noxious gases. Here are some of the disadvantages of the nanotechnology in textile industry. Environmental impact. Silver nanoparticle in cloths can cause a major environmental impact in increasing the concentration of silver ions in wastewater. The sludge from which can ends up in agricultural lands as fertilizer. These toxic silver ions can cause damage to the soil ecosystems in the long term. They are also harmful to microbes and aquatic organisms even at low concentration and can lead to the evolution of antibiotic resistance bacteria. The other major disadvantages of nanotechnology in textile is nanochemical particle which affect our environment is nanotitanium dioxide, which is also used in the manufacture of nanotextiles. Also has to be considered hazardous because of its potential environmental impact. When water and UV exposure are present, nanotitanium dioxide produces free oxygen radicals which are toxic for aquatic microorganisms. This can damage the ecological balance of stretch of water. However, there are still no investigations to the mechanisms of the toxicity or the impact on natural ecosystems. Improvements of the nanotechnology. When it comes to melding nano design and fashion, there are a few things materials scientists need to take into consideration. Smart textiles are an exciting technology, but when it comes to incorporating them into our everyday life, their lack of resilience become an issue. The price is high, the cost has to be reduced. There are some environmental effects by using nano silver particles in cloth. The environmental effects has to be controlled.